Welcome to section 2.2, subsets. Objective 1, recognize subsets and use the notation for subsets. So set A is considered a subset of set B, expressed as A is a subset of B if every element in set A is also in set B. The notation A is not a subset of B means that set A is not a subset of set B. So there is at least one element of set A that is not an element of set B. Okay. So for our examples here, we're asked to write whether the two sets are a subset or not a subset in each blank to form a true statement. Okay, so for A, we have set A and B, right? Is A a subset of set B? Okay, that means is all of the elements in set A within set B? And that would be no. So A is not a subset of B. Okay, B, set A says all X values were X, such that X is a letter in the word roof. And set B says Y, all Y values, such that Y is a letter in the word proof. So this is asking us, are all the letters in the word roof included in the word proof? If it's a yes, then it's a subset. If it's a no, then it's not a subset. And it is. And C. A says all X values where X is a day of the week. And B is the set Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So our question is, are all the days of the week included in the set B? Yes, they are. So A is a subset of B. Objective 2, recognize proper subsets and use the notation proper subset. So that's the notation for proper subset. So set A is a proper subset of B expressed as A is a proper subset of B if A is a subset of B and A does not equal B. The empty set, we learned that in the last section, is a subset of every set and it is a proper subset of all sets with the exception of the empty set itself. So in our examples here, we're asked to write whether it's a subset, a proper set, or both in each blank to form a true statement. So for A, we have a set A and a set B. Set A is 2, 4, 6, 8. Set B is 2, 8, 4, 6, 10. The first question is, are all elements in A within B? The answer there is true. Okay. So we know it is a subset. We know A is a subset of B. Now we want to ask ourselves, is it also a proper subset? And a proper subset means that if A is a subset, so that's a requirement, and A does not equal B, then A is a proper subset. So we know A is a subset of B. We answered that. Now, does A equal B? No, it does not. Therefore, it is also a proper subset. So this is both. Okay. All right, next one. A is all X values such that X is a person and X lives in Atlanta. B is at all x values where x is a person and x lives in Georgia. First thing, is A a subset of B? Meaning, is A contained or an element of B? Yes, because, well, A and B are both people. They're both a person. And A lives in Atlanta and Atlanta is in Georgia. So we know A is a subset of B, which is a requirement for the proper subset. But in addition to that, A must not equal B. Okay. So does A not equal B? Yes, it is not completely true because I could live in Georgia and not in Atlanta. Okay. So this also is both. All right. For the next one, we need to determine whether the subset, proper set, both, or neither can be placed in each blank to form a true statement. So for A, we have 02468, and then we have 80624. Okay. Now, 02468, are those values contained within the second subset? Sorry, not subset. Are those values contained within the set? Yes, they're just rearranged. So it is a subset. Now, is it a proper set? In order for it to be a proper set, it has to be a subset, but the sets must not equal. In this case, the sets do equal. So it is not a proper set. It is just a subset. Okay. And B, first set, X, such that all X values such that X is a parrot is the first set. And the second one, all X values such that X is a bird. Okay. Now, are parrots birds? Yes. Therefore, it's a subset. Do parrots equal bird? Well, there's many different types of birds. So it is a proper subset as well. So it would be both subset and proper. Awesome. Objective 3, determine the number of subsets of a set. So the number of distinct subsets of a set with n elements is 2 to the power n. And the number of distinct proper subsets of a set with n elements is 2 to the n minus 1. Okay, now 2 to the n has a power n. If you are using your TI 83, 84, 84 plus to get the power location, you would have to press the caret button. So you would press 2, and then you would press the caret button, and then you would press whatever value n is that you are looking for, whether it's 2 to the first power, 2 to the second power, and so on, to get the value that represents that expression. Okay. So let's do a couple of examples. So we want to find the number of distinct subsets and the number of distinct proper subsets of each set. Okay. So in the first one here, we have the set A, B, C, and D. So n is the number of elements in the set, which is 4. So to find the number of distinct subsets, we're going to take 2 to the 4th power, which is 16. Then we will find the number of distinct proper subsets, which would be 2 to the 4th minus 1. Okay. 2 to the 4th is 16 minus 1, which is 15. So that means we have 16 subsets and we have 15 proper subsets. Okay. All right, let's do the next one. B. all x values such that x is an element of the natural numbers and x is greater than or equal to 3 and less than or equal to 8. So these values, let's list them out using the roster method, would be 3, 4, 5, 6, 7, and 8. So the number of elements here is 6. So 2 to the 6th power will equal 64. So 2 to the 6th power minus 1, which would be 64 minus 1 is 63. So we have 64 distinct subsets, and we have 63 distinct proper subsets. Okay. All right. Let's do a couple more. Again, we're calculating the number of distinct subsets and the number of distinct proper subsets for each set. So for our first one here, we have the set 2, 4, 6, 8, 10, and 12. So the number of elements here is 6. So 2 to the 6th power is 64. That is the number of distinct subsets. To find the number of distinct proper subsets, we'll take 2 to the 6th power. Let me erase that right here. And we will subtract 1. So that is 64 minus 1, which is 63. So we have 64 subsets and 63 proper subsets. Okay. And B, all x values such that x is an element of the natural numbers and x is greater than 2 and less than 6. So let's write out the elements using the roster method. So that would be 3, 4, and 5 because x can't equal 2 or 6. So the number of elements here is 3. So 2 to the 3rd power is 8. Then we're going to take 2 to the 3rd power minus 1, which is 8 minus 1, which is 7. So this set has 8 subsets, 8 distinct subsets, and 7 distinct proper subsets. Awesome. Good job. Well, that concludes section 2.2.